Power quality issues cost industries billions every year, and most of them never get properly diagnosed. If you work in the field, you know the frustration. This podcast is for you. Welcome to Power Quality Decoded, brought to you by Power Monitors Incorporated. Find us at powermonitors.com. Let's dig in.
Good afternoon, everyone, and welcome to today's white paper webinar. And today we're here with Vinny, and we're talking about Merlin, and specifically how Merlin looks at strip charts. Merlin is our power quality AI assistant in PQ Canvas, and Merlin looks at strip charts, looks at waveforms, looks at compliance reports, and applies a whole slew of heuristics that we programmed in and applies IEEE standards to what it sees. And so it's doing a visual analysis in many of these cases with waveforms and strip charts, and that's the ground level evidence that it's looking at. And then there are layers that interpret this. But here we're going to talk more on the strip chart analysis. We're going to talk about how that works and show this in PQ Canvas, and also talk about how it relates to the top level analysis that Merlin gives you. So when you're using Merlin, you don't always dive into this level of detail, but if you need to, or there's evidence in here that you want to access, we'll talk about how to get to that and how Merlin did this.
Thank you, Chris. Hi, everyone. My name is Vinny. So today we're going to be, as he said, going over the strip chart aspect of Merlin. So in many investigations, the strip chart is the first place that you go to look at. And to understand it, you have to go through them, and it tells the entire story of the whole recording. But having to go through them is a lot of work. And so what Merlin really does is it gives you what it finds as some of the most interesting areas or for things like that. As we said, manual review was traditionally inefficient. So any 7-day recording can contain thousands of interval data points. And when you look at it from a high level, you don't really see much. And so you really have to dig down to it. And so for a human, reviewing the data is a constant battle between that volume and attention. It's tedious to scroll through them all. What Merlin really does is it helps alleviate a lot of this. So it shifts it by applying an AI-driven pattern for the entire strip chart recording. So rather than treating each channel in isolation, it evaluates the whole context of the data. And so what it finds in the strip chart is organized into 6 distinct analysis modules: voltage sags, voltage swells, loose neutrals, voltage regulation, flicker, and harmonics. So to start, when we go into PQ Canvas and look at any Merlin analysis, so this is a recording from a residential customer. You'll notice there's a strip chart section over here, and here you can see the distinct breakdown of what it finds inside the strip charts. So over here you have each of the 6 sections, and any of these numbers, you can look at the legend over here to look at what the severity means as it correlates between them. So each time that you click down, it'll have a detailed analysis where you can actually go through and see what it finds for this specific area. One, like voltage swells, it sees as a high severity, which means that this is probably something that we're going to want to take a look at. Something like loose neutrals that has a severity of 1 means that it's not really affecting any of the recordings, doesn't really find anything of interest to us. And so all of this helps us by really pointing us in the right direction of this analysis. So the first one is going to be voltage sags, context and attribution. And again, as we said, its primary goal here is attribution, distinguishing between voltage sags caused by a customer's own equipment and those originating from the utility grid. For each of the sag that it identifies, there's a clear determination, customer source or utility source, along with supporting evidence. So one of the things that's cool is when you actually look at it, Merlin will support what it finds with evidence. You can go in and investigate it further. So you receive a definitive answer that they can present to a customer or use to prioritize field of work. So in this one, we have a severity of 5, which is about moderate. You can see it says that it detects that there's minor voltage dips with load spikes, rare deeper utility dip. And it gives you the whole analysis of everything that it finds.
Yeah, here, for example, like Vinny said, it's kind of a mixed bag here. There are voltage sags that are caused by the load, by the customer, along with utility-caused deeper sag, which is probably an upstream fault. So this is the one-line summary, and based on the size and frequency of both of those, that gives it a 5 in severity moderate. And then here it's telling exactly what it saw, when it saw. Here's where it saw the deepest sag. It's not accompanied by a significant current change, so it knows is from the utility side, and then here is its what it saw with customer load. So we see current spikes in the 130, 140 amp range that are causing 2 to 4 volt dips. So Merlin does this analysis for you. So you could see this yourself in the strip charts. And if we go to the raw data, here is the RMS voltage and current strip chart. So if you're doing this by hand, you would zoom in and see these current spikes and current sags. Some of them line up with the current and some of them don't. So the ones that do line up are caused by the customer. The ones that don't are caused by the utility. So for example, these little voltage changes, those are caused by the customer. So you got 90 amps here and you got a couple of volt sag. Others are not. But Merlin does this kind of grunt work for you. And that's where it shows up here in the strip charts. Now, as the paper talks about, you can start at the top with the overall power quality report. And here is the summary of the entire recording, from a high level. Each of the issues that it saw in the recording. Voltage regulation is really the biggest part of the story here in this recording, with overvoltage, some voltage swells, sags, and generally is it utility leaning or customer leaning in terms of cause, and the evidence, the snapshots. So often you would just stay at the high level at the Merlin top level analysis, and here voltage swells and steady state voltage regulation are the highest priority ones. So we'll jump to voltage regulation, and here it's telling you what it found. And this is a combination of strip chart evidence and the compliance reports for NCC 84 and even waveform captures. But if we want to go deeper, if we want to see more evidence or understand more of why it claims what it did, we can go to the strip charts. And if we're talking about voltage regulation, you would click on the voltage regulation strip chart. And here, as Vinny pointed out, these severities are higher for voltage swells and regulation. They're 7. That's closer to the high. This is where the real problem is. So here we can click on that and see what Merlin saw out of these strip charts. When did it see it? What did it see? It's talking about the fact that it's going to almost 7% high. And here's the voltage ranges and how it relates to NCC 84. And at the bottom, we have these regions of interest. These are particularly interesting sections of the strip chart that Merlin has seen. So this shows what it was and the start and stop time. So you can look in the strip chart to see this for yourself. And if we go into the strip chart with a manual analysis, we'll see that, well, yes, this is a whole block here where the voltage was high for almost an entire day. So Merlin obviously picked up on this. This is a very straightforward one, and gave a compliance-related analysis of it and arranged this by severity. So in general, that's how Merlin works. It's looking at waveforms. It's looking at strip charts and looking at compliance. So here, voltage regulation is a 10, severe because of this, big fail on NCC 84.1. And then putting all those pieces together in the top level report. And so here, this paper is focused on the strip chart layer. This is one of the ground layers of Merlin actually looking at data. This is one of the hands-on pieces of Merlin. And we can see some of these that are low severity, like loose neutrals. As Vinny said, that's severity 1, basically not a problem at all. There was no loose neutral here. So this part of Merlin is focused on purely, is it a loose neutral problem? And it's looking for those signs of one leg going up, one leg going down, but it didn't find that at all because this is not a loose neutral issue. So these are low severity, and then here are the high severities. So this is the strip chart section of Merlin is one of those hands-on Merlin looking at raw data layers. And so if you want to look with Merlin, just click on one and it'll tell you exactly what it saw and exactly where it saw it. But again, start at the top level because this ground level evidence layer feeds all the way up to the top. And of course, you can always go back to the raw data yourself and look at it. Now, another aspect that's new since the paper was released is the chat. You can ask Merlin about the recording. I'm going to start a new chat about the voltage regulation.
It's nice UI.
Vinny actually created this user interface.
Oh, did I?
So when you're chatting with Merlin, Merlin knows everything about that recording in its memory. So you're chatting with the PQ assistant. that is familiar with all the IEEE standards and exactly what happened in this recording itself. So telling about the voltage regulation in this recording. Well, it's the main problem, and here's what it saw. You're sitting at 122 to 128 volts most of the time. And then there was a major overvoltage episode on the evening of the 13th. We were at 133 to 136 volts. We're over 10% high. That's an overvoltage condition. That's a big problem, and Merlin knows about that. Now, we can also say, well, apart from regulation, what else is a problem here? And you can brainstorm with Merlin. You can ask it, say, what if we upsize the transformer? What would that do to the flicker? Would that bring us into compliance? You can have it walk through some impedance calculations with you. If you give it the transformer size and the service conductor size, it will take that into account. You can brainstorm solutions with Merlin. So it's a very good engineering partner. So here we're talking about, besides overvoltage, we have harmonic distortion is moderate, 5 to 6%, in some cases approaching 8 to 10%. That's kind of a high. Pointing out that we didn't record voltage distortion, but it's pulling this from the waveform captures. So it's looking at everything and gleaning everything it possibly can from this. Some rapid voltage changes, some flicker, not too bad, but noticeable. So it will give you a good summary of the recording, but you can also drill down and ask it questions directly from that. Well, if you have any questions about the paper, feel free to type them in the questions box. Or if you want to try Merlin, simply go to our website. And you can, the link is right here to request demo access. So with this, you could actually look at these files and play with Merlin yourself to see what it can do. Your question is, the data stay within PQ Canvas? Is this Merlin native to PQ Canvas? Yes, Merlin lives inside of PQ Canvas. Now, Merlin will soon be able to ingest other data besides power quality files from our recorders. Merlin will be able to import PQDIF or ComTrade format data. So if you have data from relays in a substation or permanent monitors, maybe smart meters that have PQ ability, Merlin will be able to ingest that by putting it inside PQ Canvas and letting Merlin analyze it. So Merlin will be able to analyze more than just our power quality recorder. So if your device can produce waveforms or strip charts of voltage or current or other power data, Merlin can analyze that. That's all the questions we have now. Again, if you have a question later, give us a call anytime at 1-800-296-4120 or send an email to support@powermonitors.com. Thanks for attending, everyone. Everyone have a great afternoon.